Our solar system consists of a central star, 8 planets, and numerous smaller bodies like dwarf planets, asteroids and comets. The arrangement of these celestial bodies is a result of the solar system's formation process. In its early stages, only rocky materials could withstand the intense heat near the Sun, leading to the formation of the inner terrestrial planets: Mercury, Venus, Earth, and Mars, which are all relatively small with solid rocky surfaces. Conversely, materials that typically exist as ice, liquid, or gas settled in the colder outer regions. Here, the gravitational pull of these materials led to the formation of the gas giants Jupiter and Saturn, as well as the ice giants Uranus and Neptune. Approximately 4.5 billion years ago, our solar system emerged from a dense cloud of interstellar gas and dust. This cloud collapsed, possibly triggered by a nearby supernova explosion, forming a spinning disk known as a solar nebula. At the center of this disk, gravitational forces caused matter to accumulate, resulting in a dense core where hydrogen atoms fused to form helium, initiating nuclear fusion and giving birth to our Sun. The Sun accumulated more than 99% of the mass in the solar system. Meanwhile, further out in the disk, clumps of matter collided and merged, gradually forming larger objects. Some of these grew large enough for their gravity to shape them into spherical bodies, becoming planets, dwarf planets, and large moons. However, not all material coalesced into planets. The asteroid belt, for instance, consists of remnants that never formed a single cohesive planet. Other remnants formed smaller bodies such as asteroids, comets, meteoroids, and irregular moons. Our solar system extends far beyond the orbit of the planets that circle the Sun. It encompasses the Kuiper Belt, located beyond Neptune's orbit, which is a sparsely populated ring of icy bodies, with most smaller than the most famous Kuiper Belt object, the dwarf planet Pluto. Further out from the Kuiper Belt lies the Oort cloud, a vast spherical shell enveloping our solar system. Although never directly observed, its existence is inferred from mathematical models and observations of comets believed to originate there. The Oort cloud consists of icy fragments of space debris, some as large as mountains, orbiting the Sun at distances up to 1.6 light-years away. This cloud of material is extensive, ranging from 5,000 to 100,000 astronomical units, AU. Functioning as the outer boundary of the Sun's gravitational influence, the Oort cloud is where objects in orbit can change direction and potentially return closer to the Sun. Beyond the Oort cloud lies the heliosphere, a bubble formed by the solar wind, a flow of electrically charged particles emanating from the Sun in all directions. The boundary where the solar wind slows abruptly due to pressure from interstellar gases is known as the termination shock, occurring between 80 and 100 AU. Two NASA spacecraft launched in 1977, Voyager 1 and Voyager 2, have both traversed the termination shock, Voyager 1 in 2004 and Voyager 2 in 2007. Voyager 1 entered interstellar space in 2012, with Voyager 2 following suit in 2018. However, it will take thousands of years for these spacecraft to travel beyond the Oort cloud.